In this video, we're going to look at a network problem, which is called the shortest path problem. So in this case, we're going to formulate this problem as a deterministic dynamic programming. So let's start. Here's the example. Somebody called Joe Cougar lives in New York City. He plans to drive to Los Angeles to seek fame and fortune. However, his money is limited, so he has decided to spend each night on his trip at a friend's house. Joe has friends in Columbus, Nashville, Louisville, Kansas City, Omaha, Dallas, San Antonio, and Denver. Joe knows that after one day's drive he can reach Columbus, Nashville, or Louisville. So let's look at this diagram here. And then what the sentence here says, after one day's drive, he can reach Columbus, Nashville, or Louisville, means that he starts his first day in New York, and then after one day of driving, he may reach one of these three cities. Okay, so this is how to read this diagram. So these three cities, Columbus, Nashville, and Louisville, they are all one-day drive from New York. And then after another day, there are three cities that he may reach: Kansas City, Omaha, Dallas. And then the next day, there are two possible cities: Denver and San Antonio. And then finally, Joe will arrive at Los Angeles. Okay, so if we continue reading this description, it says that after 2 days of driving, as I've said before, he can reach these three cities here: Kansas City, Omaha, Dallas, and then 3 days of driving, he can reach either San Antonio or Denver, and finally, he can reach Los Angeles. Now, in the shortest path problem is that we have a starting point. In this case, it is New York, and then we have also our final destination point. In this case, it is Los Angeles. And then the question is how to minimize the distance or the number of miles traveled from the starting point to the destination point. Okay, so this number here, 550, 900, and so on, they show the miles or the distance in miles between one city to the other city. And again, the purpose is that we would like to minimize the distance traveling from New York City up to Los Angeles. So to formulate this problem and also later to solve this problem, we are going to use the idea of working backward from the end. Because when we look at this problem near the end of the problem, it becomes a simpler problem. So what I mean is that suppose Joe is already on his 4th day driving, means that Joe is already either at Denver or San Antonio, then the decision is very simple, right? Joe wants to reach Los Angeles, then if he is in Denver, then just go to Los Angeles. If he is already in San Antonio, it's the same, just go to Los Angeles, and then it's done, right? Now we are going to use this idea to formulate this problem and to solve this problem as well, such that we get the answer that if the starting point is from New York, where should he go next? And then after the 2nd day, where should he go next, and so on. But you see that we apply the idea that we are going to look at a smaller problem, so only from day 4 to day 5. And then we are also going to look at starting from the end to the beginning. In other words, we are going to work backward. So at day 4, after 4 days of driving, Joe may be at Denver or maybe at San Antonio. So if I ask you a question, at day 4, what is the remaining distance for Joe to reach LA? What would be your answer? Well, the correct answer should be It depends on where we are or where Joe is at the beginning of day 4, right? You cannot say what the distance is before you know where you are at the beginning of day 4. Because if you are in Denver, then the distance is 1,030 miles remaining distance to reach Los Angeles. But if you are in San Antonio at the beginning of day 4, then the remaining distance is 1,390 miles. So to answer that question, it really depends on the information about where we are at the beginning of day 4. Okay. In the terms of dynamic programming, day 4 is called the stage. Okay, so we have 4 stages. Day 1 we start at New York, day 2, day 3, and day 4. And day 4 we may start either in Denver or San Antonio. And that information is called the state. The state or the condition of you at the beginning of day 4. So where we are at the beginning of day 4, the where we are information is called the state, and day 4 is called the stage of our problem. So to answer the question of what is the remaining distance to reach LA at day 4, let me shift your attention to this word depends, right? Because it depends whether we are in Denver or we are in San Antonio at the beginning of day 4. So we may define FTI, which is the length of the shortest path from city I to Los Angeles at stage T. So let's look at the numbers first. F48 equals 1,030. So F48 means that the length of the shortest path or the shortest distance from city number 8, which is Denver, to Los Angeles at stage 4. So this thing really answers this question with the word depends. If we are in Denver at the beginning of day 4, then the remaining distance is 1,030. The remaining and shortest distance to reach Los Angeles. If we are in San Antonio or city number 9 at the beginning of day 4, then the shortest distance to reach Los Angeles is 1,390, right? So we can see that we kind of having two answers here because it really depends on where we are at the beginning of day 4. If we are at Denver, then the remaining distance is 1,030, which is F48. And then if we are in San Antonio, the remaining distance is 1,390, which is F49. Okay. And then I would like to emphasize that whenever you have a notation, let's say FTI, you have to explain all the indices. So T means stage T, and then I means the city I, where we are at the beginning of day T. Let's go backward and then look at a bigger problem. So in stage 3, if I ask you a question, where will we be at the beginning of day 3? Are we going to be in Kansas City, Omaha, or Dallas? Well, the correct answer is that we don't know yet at this moment because we work backward. So we don't know yet for sure at day 3 where will we be at the beginning of that day, because we're working backward and we only get the answer after we reach the beginning of this problem, the actual problem, where we start at New York City. But at this point, because we start from the end and now we have only reached stage 3, we do not have this answer yet. As the consequence, we need to compute the distance to LA with respect to if we begin day 3 in Kansas, if we begin day 3 in Omaha, and if we begin day 3 in Dallas. So we still have this if, because at this point we don't know yet where will we be at the beginning of day 3. And again, the information of where we begin day 3 is called the state. So let's look at the state of Kansas City, which means that we imagine if we start day 3 in Kansas City. So if we start day 3 in Kansas City, we have two options. We go from Kansas to Denver and then to LA, and then we can also go from Kansas to San Antonio and then we go to LA. Let's compare the distance. If we begin day 3 in Kansas, then we go to Denver, the distance is this 610. We denote this as C58. So the cost or the distance from city 5 to city 8. And then because our final destination is Los Angeles, you cannot stop at this city, Denver, right? So you must add 610 plus the distance from Denver to Los Angeles. We have got the notation from Denver to Los Angeles, which is F48, right? Or this is 1030. You can check this on the previous 2 slides, I think. So F48 is the length of the shortest path from city number 8 to Los Angeles at stage 4. Again, why do we need this plus here? Because if you only use the distance of 610, means that you have only reached Denver. You have not reached Los Angeles yet. Okay, so same here for the other option from Kansas City to Los Angeles. You need to add the distance from Kansas to San Antonio, 790, but plus F49, because F49 is the shortest distance at day 4 if we begin at city 9, San Antonio, which is 1390. And then when we compare these two options, we can say that if we begin day 3 in Kansas, it will be better to go with the first option. So go to Denver and then to LA. So that's the better options if we begin day 3 in Kansas. Again, let me emphasize the word if. If we begin day 3 in Kansas, this is the better option. Or we can also use this notation here. So F35, which means that if at the beginning of day 3 we start at city number 5, which is Kansas City, we compare, so this curly bracket means that we compare two options that we have, and then we take the option with the minimum distance, with the smaller distance, and then the better options is the one that we mark with an asterisk here. And so the better options is to go from city 5 to city 8. Okay, so let me recap. If we begin day 3 in Kansas, the better option is to go to city number 8, which is Denver, with the distance of 1640 starting from Kansas to reach Los Angeles. And this number here, 1640, is F35. Now what about if we begin day 3 in Omaha? Well, we have two options. We may go from Omaha to Denver to Los Angeles, or from Omaha, San Antonio, and then Los Angeles. Same as before, we need to compare these two options, which gives us the shorter distance to reach Los Angeles. So again, C68 means the cost or the distance from Omaha to Denver only. So C68 means that 540 is the distance from Omaha to Denver, But do not forget to add F for 8, the distance from city 8 when we begin day 4 at city 8. And we get that number, and then we compare that with the other option, and same as before, we take the option with the shorter distance, or in other words, in this case we have calculated F36. Again, F36 is the shortest distance, so F is the shortest distance from city 6 up to Los Angeles if we begin day 3 in city 6. So the shortest distance is 1,570 to Los Angeles if we begin day 3 in city number 6, Omaha. Okay, again, this curly brackets means that we compare two possible options, these two possible options, and then we find the minimum one and then denote the minimum option with an asterisk here. So to recap, if we begin day 3 in Omaha, then the best decision with the shorter distance is to go to city number 8, which is Denver. Let's do the same thing if we begin day 3 in Dallas. You compare two options. Either you go from Dallas to Denver from 7 to 8, or from Dallas to San Antonio 7 to 9, and then the shorter one you mark it with an asterisk. So here among these two options here, the better one is to go from Dallas to San Antonio, such that we will reach LA with a distance of 1,660. So this is F37. So to recap stage 3, we have F35, F36, and F37, because at the beginning of day 3, we may be in city 5, we may be in city 6, we may be in city 7. That's why we have F35, F36, and F37. And let's say for F37, we have these curly brackets because we compare two options, going to city 8 or going to city 9. And then we compare these two decisions, and then we denote the better decisions, the best decisions among all options with an asterisk. Means that if we are in city 7 at the beginning of day 3, then the best decision would be going to San Antonio or city 9. We can also say that the asterisk here means that whenever later in the stage 2, when we need F37, we always use the value of 1,660, which means that if we begin day 3 in Dallas, then the best decision would be going to San Antonio, because this represents the best decision for this condition, the best decision for the condition that we start day 3 in Dallas. So we whenever we need F37, we will use the value of 1,660. In stage 2, we will see that we will need the value of F35, F36, and F37. Okay, we work backward again. Now we are at stage 2, and you can see the problem becomes even bigger. But again, we still cannot say for sure where we will be in day 2. We may be in Columbus, we may be in Nashville, we may be in Louisville. So we have F22, which means that if we begin day 2 in city 2, Columbus. From Columbus, we have 3 options. So again, we have a curly bracket. We have 3 possible decisions, going from 2 to 5, Columbus to Kansas City, from 2 to 6, Columbus to Omaha, from 2 to 7, Columbus to Dallas. To decide which decision is the best, Again, we sum the decision. Let's say C25 means the distance from Columbus to Kansas City plus F35. Okay, so this is where we use our calculation from the previous stage. So let's summon F35, F36, and F37 that we have calculated in the previous slide. And then so if we decide to go from Columbus to Kansas City, the total distance would be C25, the distance between Columbus to Kansas City itself, and then add the distance from Kansas City, City 5, to Los Angeles. Okay, and then compare it with C26 plus F36, and then C27 plus F37. Take the minimum among these three possible decisions, and the best decision is that if we begin day 2 in Columbus, the best decision would be going to Kansas City or City 5. Now here's the recap for stage 2. We have F22, F23, and then F24. And then same as before, for let's say F22, we have this curly brackets and then 3 possible decisions. For F23, we also have a curly bracket with 3 possible decisions. F24, also we have 3 possible decisions, and then we take the decision with the minimum total distance to reach Los Angeles. We move backward again, and now we are at the original starting point, which is New York City. So from New York, we have only F11 because we know for sure that at the beginning of day 1, we are in New York City. Okay, so that's why in the stage 1, we only have F11. Remember, in stage 2, we have F22, F23, F24, because at day 2, at the beginning of day 2, we have 3 possible cities. But at the beginning of day 1, we only have 1 possible city, which is New York City. Okay, from New York City, we have 3 possible decisions: going to City 2, going to City 3, going to City 4. Same as before, we have a curly brackets here to say that we are going to compare these 3 possible decisions and then take the one with the minimum distance to reach Los Angeles. So the distance here, the decision with the smallest distance here is going from New York to City 2, which is Columbus, and then the distance from New York to Columbus is 550, but do not forget to add the distance from Columbus to Los Angeles, and that is represented by F22. So you see that at the beginning of day 1, we start in New York City. If our decision is going to Columbus, then we will start day 2 at City 2. If our decision is going to City 3, then we will have F23. If our decision is going to Louisville, we will have F24. In other words, we will start day 2 at City 4. Okay, so here's the pattern, and then from here we know that the optimal distance is 2,870 from New York to Los Angeles. Now, to know which cities should we visit at day 2, day 3, day 4, and so on, we just need to follow the stars or the asterisks here. So from F11, you see that the asterisk is for this decision, means that from 1 you go to City 2, right? Because this is F22, means that the best decision is going to City 2. And you look at your computation of F22, and then you have an asterisk in this row, which corresponds to F35. So then you go to F35. Take a look at the asterisk again, and then it is here, corresponds to F48, and then you go to F48. So the optimal path is that we go from city 1 to city 2 to city 5 to city 8, and then from city 8 to Los Angeles or city 10. And the total distance for that optimal path is 2,870. So we have solved the problem of Joe Cougar going from New York City to Los Angeles, and then we have obtained the optimal path with the optimal distance of 2,870. So we have solved the problem.